Hello everyone, welcome to the class once again. I hope you are doing good and in the best of your health. So in the first exercise, we have completed the first 5 questions based on this chapter, that is mechanical properties of solid. We have already completed the JEE advanced pattern question. The next 6 also will entail us in better understanding the concepts used in this chapter. So without taking more time, let's go to the question number 6 of this exercise. Question number 6. Two rods of different materials having coefficient of thermal expansion alpha 1, alpha 2 and Young's modulus y1, y2 respectively are fixed between two rigid massive walls. The rods are heated such that they undergo the same increase in temperature. There is no bending of the rods. If alpha 1 is to alpha 2 is equal to 2 is to 3, the thermal stresses developed in the two rods are equal provided y1 is to y2 is equal to a 2 is to 3, b 1 is to 1, c 3 is to 2 and d 4 is to 9. I hope that you have understood the scenario of the question and you can draw the picture in your mind, and even you can draw the picture as I'm going to show you all here on the board. It says that we have got two rods. Now you refer to this of different materials, that means Young's modulus will be different for both the rods. If it's y1 for one, y2 will be for other. Having coefficient of thermal expansion alpha 1, alpha 2. That is, one has coefficient of expansion as alpha 1, the other one has coefficient of expansion as alpha 2. And remember that we are talking about coefficient of linear expansion, that's given as alpha 1 and alpha 2. Now they are fixed between two rigid massive walls. The rods are heated such that they undergo the same increase in temperature. Now see here. For the first statement, let me draw these walls across which they are fixed. The rods are fixed in this sense. This is one part, one rod. It has got coefficient of thermal expansion as alpha 1 and Young's modulus as y1. Then we have the second rod. As you can see, we have a second rod. For this rod, we are provided with coefficient of expansion as alpha 2 and Young's modulus as y2. We all know that the extension, the stretch, the expansion, the elongation in any rod, in any metallic substance is given as L alpha delta T. This is the expansion, this is the actual increase in length equal to L alpha delta T. That is what we know about. Next thing you see here, Young's modulus is given as y equals to F upon A divided by strain, that is delta L upon L. So let me write delta L upon L in this way. So we can write Young's modulus equal to FL upon A delta L. From this, let us try to relate both this equation and get to the final relation that we needed, that we actually require in this question. Now see here, there is no bending of the rods if alpha 1 is to alpha 2 is equal to 2 is to 3. This is what that has been given to us. The thermal stresses developed in the two rods are equal. So we have to actually equate thermal stresses developed. That means F by A in both the rods will be equal. Now you see here, F by A, if I write F by A, that will be equal to Y divided by Y into delta L will go here. So you will get Y into delta L by L. Now just observe from this equation number 1, let me write this as equation number 1, delta L by L, that will be equal to alpha delta T, quite obvious. So let us write Y alpha delta T. This will be the value of stress developed in any rod. It's given that the stress developed in both the rods are equal. So what we can do, we can actually equate the stress in both the rods. So let me keep this formula, let me rub this above portion, let me rub this. This is not required now, and I hope that you would have taken note of these equations. Now it's given that stress developed in one is equal to stress developed in second. So clearly we can write that Y alpha delta T for the first one will be equal to Y1 alpha 1 delta T is equal to Y2 alpha 2 delta T. This is what that has been given to us. Now see what is needed. First of all, I have used delta T same for both the rods because it says that the increase in temperature is same for both the rods. Now you see here we are required the stress in the two rods are equal provided y1 is to y2 is equal to. We need to find the ratio y1 is to y2. So let me write here y1 by y2 is equal to alpha 2 by alpha 1. Let me rub this part. I hope you would have noted down this alpha 2 by alpha 1. Alpha 1 by alpha 2 is given 2 by 3, so alpha 2 by alpha 1 will become 3 by 2. So y1 is to y2 will become 3 by 2. That is the obvious answer for this question. So 3 is to 2. So let's see that option number C correctly matches. Rest all option incorrect, incorrect, incorrect. So I hope that would have understood how to solve such kind of question. Only a few relations. Two concepts are used here. First of all, we have used Young's modulus concept and we have also used the concept of linear expansion. If you have not studied yet linear expansion, don't worry, this is a basic formula that I have used here. And this question has been asked in previous year examination. So I believe that you would be understanding that what kind of questions do come in your examination. Let's go ahead with the next question of the day. Question number 7. The following 4 wires are made of the same material. Which of these will have the largest extension when the same tension is applied? We are given the dimension of 4 wires, but only constraint all the 4 are of same material. If the material is same, we can say that Young's modulus will be same for all the 4 wires. Now you have to only compare what is the extension in the length extension produced in each of the 4 wires. First of all, we know, let me write down the Young's modulus formula and then let me write the extension produced. Y equals to F by A delta L by L. This is what we know. So delta L will become, delta L you take here, you will become FL by AY. Now you see here, it says that FL by AY, delta L is what is required. So let us see what we need. Length is different, diameter is different. That means radius will be different. That means area of cross section will be different. Same tension, that means same force is applied. So let me write here, can we write this as F by Y and let me write this as L by A. So from here can we write, since F by Y is constant for all the 4 wires, F by Y is constant, so delta L will be proportional to L by A. I hope that you would have understood how we have got this. Now just compare. Can we write this as delta L is proportional to L upon pi r square? Quite simple. R can be written as d by 2. So this will be d square by 4. So we can write delta L will be proportional to L upon pi d square by 4. So 4 you can take here and then you can write delta L will be proportional to L upon d square. You can write in this way. It will be proportional to L upon d square. Compare all the 4. Compare all the 4. What we need to do. Okay, now see, all 4 are given, the length is given in centimeter, diameter is given in millimeter. So need not to worry, you can keep the length as in centimeter and diameter in millimeter. You have to just check the magnitude, whose magnitude is larger for this given ratio, L by d square. So checking option 1, let's check option A. Checking A will be having L upon d square will give us, the length is 50 centimeter and diameter is 0.5. So you are going to get 50 divided by 0.5 into 0.5. Only magnitude I require. I am not going to write this as into 10 to the power minus 3. I am not going to multiply and 10 to the power minus 2 here to make it into proper SI units. I am not going to do that because that's not required. You see here, if we solve this, this will go 0.5, this will go 100 times. And 100 upon 0.5, if I remove this decimal, I have to add here 0. So 1000 by 5, we will get 200. For option A, we have got 200 as the magnitude. Checking option B. So for B option, L by d square, we are going to get the length, you see, 100, diameter 1. So 100 by 1 square will give us 100. So B is Incorrect, because already A is larger than B. C, length is 200, diameter is 2. Length is 200, diameter is 2 whole square. When you do 2 whole square, 2 whole square will be 4, 200 by 4, that will give us 50. So C is also incorrect. Checking option D. Length is 300, diameter is 3. Length is 300, diameter is 3. 300 by, first of all, 300 by 3 will give you 100, 100 by 3 will give you 33.33 something. Quite obvious. The largest one among 200, 150 and 33.33, the largest one will be obviously 200. So option number A is the right answer, because we need to check which one has got the largest magnitude. That's option number A. So A is the correct answer. Rest all options are incorrect. I hope that you have got how to solve such kind of questions. This was a good question, and this question has been asked in previous year examination. So I believe that you would have understood what kind of questions do appear in your examination. Will you proceeding with the next one? Let's go ahead with the next question of the class. Question number 8. Block of mass capital M is suspended from a wire of length capital L. So I hope that with the first statement you can make the picture. Area of cross section A and Young's modulus Y, the elastic potential energy stored in the wire is half m square g square L by AY, half mg by ALY, half m square g square A by YL, half mgy by AL. First of all, it's advisable that you can also check as per the dimensional relation which option is correct. That is, I'm leaving up to you, you can do it. I will do it systematically, I will do it accordingly, sequentially, each step I'm going to apply. You can apply the dimensional method also to actually eliminate some of the options. Some of the options may not be dimensionally correct, so that can be eliminated. You must be knowing that if any option is not dimensionally correct with the required result, you can eliminate those options. Next, it's required the elastic potential energy stored in the wire. We have already derived the formula for elastic potential energy that will be stored in a wire when it is actually suspended with the help of a mass. So you see here, if we have a wire, it's suspended with the help of a mass m. Now see here, the energy stored is equal to half. This is the simple formula that I am going to use here, which I have taught also to you all in our regular class, and I am going to systematically use it. Half into stress into strain into volume. That is the potential energy stored in the wire. Half into stress into strain. So we can write half stress is F by A multiplied by strain delta L by L, and volume can be written as A into L. This is what we can write about the potential energy. Now you see here, we can cancel A and A here. We can cancel A and A, and rest of things let's try to understand how we can evaluate. We are left with delta L by L, and F we are left with F. We know F will be equal to mg. So let me write at the sideways somewhere, let me write here F will be equal to mg. Now we have to put the values only here. So before cancelling the terms, because we can cancel area, length and length, you can see that, but we will be troubled with F into delta L, how to do that. So you see here, we can write Young's modulus is equal to F by A, first of all F by A, and then delta L by L. This is what we can do, F by A delta L by L. So I have written in this way. Now clearly we can write delta L by L. Delta L by L will give us F by AY. That's quite obvious. Delta L by L will give us F by AY. So if I put here half F by A multiply with F by AY multiply by A into L. Not a problem. Now you see here what things are given. Block of mass m, so F we have is suspended from a wire of length L, so length is also given. area of cross section A and Young's modulus Y. All our things are given. Now we have to directly put up the values. So you see here, this will come out to be, you see the A and A now you can cancel out. This can be cancelled. You will be left with half. F square will be mg whole square divided by A, Y, and you will be having here L. So this will come out to be half m square g square, and let me use capital L. I have not used capital L because in your question it's given everywhere capital L. So let me use capital L everywhere because it's given capital L. Divide by A into Y. Here also you may change this as capital L because it's given in your question, that is capital L. Clear to us? So now let's see, this is the value of potential we obtained, half m square g square L by AY. Let's go ahead and check. Half m square g square L by AY, option number A clearly matches, rest you can eliminate. This is what we find, and if you want you can also check dimensionally which option will be the correct answer. This formula we have derived in our regular class. Potential energy per unit volume is half into stress into strain, and potential energy if you want to find out for the entire wire, just multiply with the volume, the value of stress and strain, multiply by half. This is what we have learned. I'm not going to derive this entirely how we have reached to this equation. If you want the derivation, you can watch the class where we have done the derivation portion. So it's advisable to remember each of the formula that we learn in the class, and I have asked you all to also derive on your own and remember the basic formulae. Let's go ahead with the next question, 9th one. If the ratio of the lengths, radii and Young's moduli of steel and brass wires in the figure are A, B and C respectively, then the corresponding ratio of increase in the length would be A, 2A square C by B, this is a small c, don't worry about the capital C, B, 3A by 2B square C, and C, 2AC by B square, and D, 3C by 2AB square. See here in this question, it's given that the ratio of length of steel and brass, I will be using suffix S for steel and suffix B for brass. So given that length of steel upon length of brass is equal to A, next thing that has been given, their radii are the ratio B. So let me write down as radii of steel divided by radii of brass will be given as B, and third we are given that Young's modulus of steel upon Young's modulus of brass is equal to C. This is what that has been given to us. Then the corresponding ratio of increase in their lengths would be, increase in length we need to compare. Before that, Y is equal to F by A delta L by L, this is what we know. So delta L will be F by AY, and here you will be having L. We need to compare the ratios. So delta L of steel and delta L of brass, we need to compare this. So we will be having F upon steel upon F upon brass, L of steel upon L of brass, then area, it's in denominator, so we will be writing area of brass multiplied with area of steel divided by area of steel, and Young's modulus is also in denominator, so Young's modulus of brass, F on steel and F on brass. You see here the force acting on the steel wire. Steel wire, you see M is hanging here and 2M is hanging here. So total weight that will be acting on the steel wire, the total force with which it is being pulled downward, that will be due to effect of M and 2M. So it will be 3M. So let me write this as, let me use this part, is equal to 3mg divided by force acting on brass wire. Brass wire as this, only weight acting is 2m, so divide by 2mg. Then you have length of steel upon length of brass. Length of steel and length of brass, that is given in the ratio as A. So let me write this as A, length, then area of brass upon area of steel. Area of brass upon area of steel, can this be written as radius of brass whole square upon radius of steel whole square? Now Young's modulus of B upon Young's modulus of steel, so you'll be having this as 1 by C. So now we are going to get this as 3 by 2 A RB by RS whole square, so you'll be getting 1 by B square. So 3A by 2B square C, this is what the answer we are going to get. 3A by 2B square C, let me write it accordingly. Hope that you have got how to solve such kind of question. 3A by 2B square C. Let's check. 3A by 2B square C, option B clearly matches. Rest all options are incorrect. Clear with the case? I hope that you have understood how to find out what weight would be acting on any wire based upon different weights which are acting at different points. Clear with this? Let's go ahead with the next question, and before that, next question, that is the 10th question of the class. Let's go ahead. 10th one. If rho is the density of the material of a wire and sigma the breaking stress, the greatest length of the wire that can hang freely without breaking is A 2 sigma by rho g, B rho by sigma g, C rho g by 2 sigma, and D sigma by rho g. This is what has been given. Rho is the density of the material. Now see here, and sigma the breaking stress. First of all, try to understand sigma the breaking stress. That means the maximum force upon area maximum that would be equal to sigma. Now let me show you, the wire is somewhat like this. Let's say this is the wire, it's hanging due to its own weight. The wire should not break the maximum length that the wire can have. Now see, the weight is, if you check here, the maximum stress would be acting at the topmost point, because due to the entire weight, a force is acting here. So let me first of all try to find out the mass of the entire wire as per its length. If its length is given as L, so what will be its weight? Now you see, one more thing is given, rho is the density of material. Rho is the density of material, so we can write that volume, or let me write its mass as per the given length. Mass will be equal to density into volume, so rho into A into L. This is what we can write about mass. Due to its entire weight, the stress that would be acting, due to its entire weight, the stress acting would be F by A, entire weight, so mg by A. So this will come out to be, mass is rho AL divided by area, and this is the, we have to find out the maximum length. So let me equate this maximum stress that it could sustain. So sigma, A and A will be cancelled out, so L will be equal to, L will come out to be, this will come out to be sigma by rho. L will come out to be sigma by rho. Let's check the option. L is sigma by rho, and one more thing, we have missed G here. So don't worry, we have missed here G. Let's add here G. So we'll be getting L is equal to sigma by rho G. Now hope that, because I missed here writing letter G, so that you can take care G. So sigma by rho G. Let's check here. Sigma by rho G. Clearly option number D matches. Rest all options are incorrect. I hope that you understood how to solve such kind of question and what kind of questions can come in your examination. These were, now with these set of 10 questions, you would have got to know what questions and what level of difficulty can be asked in your advanced exercise. We have not done integer type, we have not done assertion reason in this case, because generally the questions asked are of single choice question in this exercise. It will be rare that in this chapter questions asked will be of integer type, or more than one option correct, or assertion reason. Question can be asked, but it's not the thing that we've observed in the previous examinations. I hope that this exercise will be of great help to you all, and you would have enjoyed learning with me, and I believe that you are practicing after the class also. Keep doing that, because that will enhance your efficiency. So Thank you everyone for joining me here. I'll catch you all within the next class with some more exercises and more learning. Thank you everyone. Wish you all the very best.